What is hand-arm vibration? Vibration is a type of mechanical energy characterized by repetitive, back-and-forth motion. Hand-arm vibration occurs when this vibration is transferred from a tool, machine, or surface directly to a worker's hands and arms. This motion, known as oscillation, moves alternately in one direction and then the opposite, and can lead to serious health effects with repeated or prolonged exposure. The way vibration is transferred from a vibrating object to the body depends on several key physical characteristics of vibration. Magnitude or acceleration. Also known as the vibration level, this refers to how quickly the object is moving. Greater movement means higher acceleration. Acceleration is measured in meters per second squared. Higher acceleration increases the intensity of vibration transmitted to the body. Frequency. This is the number of vibration cycles that occur per second and is measured in hertz. The faster an object oscillates, the higher its frequency, the slower it moves, the lower the frequency. Duration of exposure. This refers to the length of time a person is exposed to vibration. Longer exposure times increase the risk of harm. Direction of vibration. The angle and path through which vibration travels through the body can also affect how much impact it has. To better understand acceleration and frequency, imagine waves hitting a shoreline. The speed of each wave hitting the shore is like acceleration. The faster it hits, the more force it carries. The number of waves per minute is like frequency. The more frequent the waves, the more consistent the impact. Similarly, with tools, those that generate higher acceleration, stronger vibration, or operate at certain frequencies pose a greater risk of adverse health effects, such as those seen in halves. Every object has a natural frequency, the specific frequency at which it vibrates most easily. This frequency is determined by the object's composition, size, structure, weight, and shape. Different parts of the human body have their own natural frequencies. For example, the hands typically have a natural frequency of 30 to 50 Hz. The arms have a lower natural frequency, around 5 to 10 Hz. These differences are influenced by factors such as body weight, stiffness, and water content. When you grip a tool, the muscles of the hand stiffen, which changes the vibration absorption and amplifies certain frequencies, increasing the risk of injury. When a vibrating tool or surface operates at a frequency that matches the natural frequency of the hand or arm, this creates a resonance condition. In this state, maximum energy is transferred to the body, greatly amplifying vibration and increasing the likelihood of damage. Resonance occurs when the excitation frequency, from a tool or machine, coincides with the natural frequency of the human body part or structure. This can result in high vibration levels, which is why it is critical to avoid operating machinery at speeds that correspond to structural or bodily natural frequencies. It is of paramount importance that a machine not be operated at a speed that corresponds to a natural frequency of the structure. Injury can occur at frequencies between 5 and 2000 Hz, but the greatest risk for fingers is between 50 and 300 Hz. The likelihood of developing halves depends on several key factors. Vibration intensity, measured in acceleration units. Vibration frequency, daily exposure duration, in hours, and total years of exposure. The vascular component of halves is primarily linked to cumulative exposure over a worker's lifetime. Studies report a wide prevalence of halves among vibration-exposed workers, ranging from 6% to 100%, with an average of 46%. This variation is largely attributed to differences in cumulative exposure among various worker populations. The latency period, the time between initial exposure and onset of halves symptoms, can range from 6 weeks to 14 years, depending on the intensity and duration of exposure. In the early stages, symptoms such as finger blanching and tingling may occur intermittently and are often overlooked. Diagnosis typically happens in later stages, once the symptoms begin to interfere with daily activities, including work. The effects of hand-arm vibration are permanent and non-reversible. The circulatory and neurological symptoms of HAVS can develop separately or together, depending on the nature and duration of exposure. The following tools are frequently associated with an increased risk of developing hand-arm vibration syndrome. Chainsaws, impact drills and wrenches, jackhammers, rock drills, sanders, saws, grinders, jackleg and stopper drills. The following is a list of occupations that are prone to the development of HAVS and the primary tools they use. Vehicle assembly worker, grinders, sanders, and buffers. Autobody repair, grinders, sanders, buffers, and pneumatic knives. Bricklayers, block saws. Carpenters, drills, saws, and nail guns. Road construction, jackhammers, and concrete saws. Tool and die, various drills. Forestry workers, chainsaws, and brush saws. Foundry workers, grinders, and chipping guns. Mechanics, impact wrenches. Millwrights, impact wrenches and grinders. Miners, jackleg and stopper drills. For more information, please contact an OCA ergonomist.